appreciate you joining us. We know that all of you are extremely interested in learning as much as you can to to really hone your diagnostic skills and your repair skills, and to really keep them sharp. And with that in mind, I'm very pleased to introduce our speaker today, who is Mr. Cecil Williams, Area Technical Training Manager for FIAT Chrysler Automobiles, otherwise known as FCA. I've known Cecil for years. We served together on the AST Committee for Skills USA. Cecil today will present an overview of the FCA eTorque mild hybrid system. And with that, I'd like to introduce Cecil. And Cecil, you can take it away now. Thanks so much.
Okay. Okay, I need to get my monitor displayed. Can we?
We've got a beach scene on right now.
Okay. I need to change screens. There it is. Is that the right screen showing now, Dave?
Yes, sir.
Okay. As Mr. Bassett said, my name is Cecil Williams. I'm with FIAT Chrysler Automobiles, or FCA is the term easier to use. Today, going to spend some time talking about something that we've introduced a couple of years ago on a couple of our products. It's right now on the Ram 1500 pickups and the Jeep Wrangler. I believe it's also on a Jeep Gladiator. I have not verified that one, but I do believe it is. And what this system is this is a one level of electrification for these vehicles. And what that's going to do, the purpose of electrification is, as most of you or all of you probably already know, is that we are trying to increase fuel economy as well as reduce emissions. The picture that you see here are two of the three engine packages that have this. This is the one on the picture on the left, and this is my startup screen. The picture on the left is the 5.7 liter Hemi with the eTorque system, sometimes called the belt start generator. And the one on the right is the 3.6 liter Pentastar V6 with the same system, a little bit different configuration, but as far as functionality, it's pretty much the same. A short overview of this is, first of all, this is a 48 volt system. Most electrification systems that we've seen up to this date or up to this point have been 400 volt, either pure electric vehicles or hybrid electric vehicles or plug-in hybrid electric vehicles, and used a 400 volt battery. This system simply uses a lot lower voltage, a 48 volt battery. It's below the threshold established by SAE as far as needing any specialized safety equipment. That threshold is 60 volts, and we're 12 volts below that. The purpose of this system is it's kind of threefold. Provides engine stop start. Okay, when I pull up to a stop sign, I'm sitting there with my foot on the brake, the engine's running, my miles per gallon is 0. If an engine is running, I'm at 0 miles per gallon. There's no reason to have the engine running other than to run the air conditioner, and I'll get to that in a little bit. No reason to have the engine running at that point if we can restart it in a timely manner to launch from the stop sign. So this is one of the ways that we are improving fuel economy and also improving emission output with it, okay? Excuse me. Also provides what we call fuel cutoff. What that is whenever we are coasting, we shut the fuel off. Whenever it provides engine braking, or helps with providing engine braking, I should say. And it does that through regenerative charging of the battery. And it also provides some electric power assist and for acceleration. I mentioned already, it's designed to increase the fuel economy and reduce emissions of the tailpipe emissions. And the bottom bullet point on this screen, the vehicles still use a 12-volt system for initial starting. So your first start of the drive cycle is going to be using a 12-volt starter, conventional starter, and also uses 12 volts for the accessories. So the only part of the vehicle that is the 48-volt system is the charging system and the engine stop-start. It uses a 48-volt battery. I mentioned that already. There is not a 12-volt generator on the vehicle. It is the 12-volt system is provided charging through a converter, through a DC to DC converter, 48 to 12 volts. And that is how all of the accessories and everything is powered in the vehicle. Every accessory I have found so far on the vehicle, and I'm never going to say I have found all of them. Every accessory is basically the same as it is on a vehicle, on this vehicle, as it is on a vehicle without this system. The 12-volt power I mentioned is routed from the 48-volt battery to the underhood PDC, distributed from there. Actually, I said that wrong. It's 12-volt power is routed from the 12-volt battery to the PDC. The 12-volt battery is charged by the 48-volt. I mentioned that. And excuse me, I mentioned also that unlike the 400-volt system in our plug-in hybrid Pacifica, the 48-volt system does not require any special safety equipment. Identification of some of the components. So the 48-volt circuitry is easily identified. It's big cabling, large cables, but you see the blue insulation. Anyone who is familiar with the 400-volt systems know that the industry standard is that everything is in orange cables for the 400-volt systems. On this, the cabling is bright blue, and there's the next screen actually shows the only routing for the 48-volt system. And this is a pickup that you're seeing here, a Ram 1500 pickup, and all of the items highlighted in red, shaded in red, are the only items that are part of this 48-volt system. You have the battery, that's up on the right-hand side of the graphic there. That is in the back of the cab behind the rear seat. You have the subwoofer on one side and the 48-volt battery on the other side. And for the stereo people, the battery's not to power the subwoofer. The cabling runs under the carpet inside the vehicle in the floor pan, comes up through the bulkhead, and from there it goes to the motor generator unit that's on the front of the engine, and I'll show that to you in just a minute. Engine packages this is on, and it is optional on a 5.7 liter Hemi and the Ram 1500. It is standard equipment on a 3.6 liter in the Ram 1500, and is optional on the Jeep Wrangler with the 2 liter. And I have now need to correct something I said a while ago. It is not available on the Renegade because the 2 liter engine's not available in the Renegade. My mistake. This is the 3 packages that it's available on. Okay. The graphic that you're seeing now gets into talking about the components, and we didn't want to leave any doubt as to what this unit was on, so we put the name of the vehicle on top of the unit. This is on a Ram 1500 pickup with a 5.7 liter engine. You see the generator, or motor generator unit, and on top of it, you see the control module. Well, this is the module that controls the system. This is also the module that serves as the controls for the motor portion and also as for the charging system. Okay, attached to that, sold as a unit. Okay, it's serviced as a unit, is the motor generator itself. And if you look at the belt on that, I think you can tell by this graphic that the belt is about 1.5 times the width of a normal serpentine belt. We've got a lot of capabilities with this unit. It has to do a lot of things. It has to start the engine. So we have to have a heavier belt on it. A little later, I'll get into some service procedures. This belt and this unit has some very specific service procedures that have to be followed closely. The power pack unit, excuse me. This is the power pack unit. This is the unit that would be located behind the rear seat. In a pickup, it's located behind the rear seat. In a Wrangler, it's actually located outside the vehicle, under the vehicle. Inside this is going to be the 48-volt battery. There's going to be also the battery pack control module and cooling fans and a set of contactors to turn the system on and off. I mentioned already that the circuitry is identified by the blue cables, okay? Inside the power pack, you see the battery pack control module, the converter, the 48 volts to 12 volt converter, the 48 volt battery, and the contactors. I believe the next graphic shows the underbody location on the Wrangler, okay? And this is where this is located on the Wrangler. The yellow piece that you see there is a lift arm, okay? It kind of looks a little funny in the first time I looked at this graphic. Encircled in the yellow line is the battery pack itself. One of the questions that came up in an earlier presentation was, how is this sealed for forwarding? This is in a sealed container. It is, what you're seeing there on the bottom is actually the skid plate. A very heavy skid plate, a little over 1/8 of an inch thick, stamped steel to go around it. I'm not going to tell you it can't be damaged, because anything can be damaged. But the battery battery pack is located under the vehicle. Okay, I'm going to back up one slide. The contactors here, this is something that whenever you turn the key on, or you have to turn the key on, the contactors close, power the system up, and otherwise the system is powered down, okay, when the key is off. Okay, some of the components, the 3.6 liter uses the motor generator unit uses a dedicated cooling system that includes an electric pump, a radiator, and a reservoir. Due to where this unit is located on the vehicle, it's mounted down low, it's in a high heat area, there's not good airflow across the unit, so we had to add a liquid air cooling system to it. One of the things I want to caution you about is that this cooling system uses the same coolant as the engine does, the same type of coolant. It is a different system. And the other piece to it is that it is a 50-50 mix of coolant with distilled or deionized water. Tap water just does the same thing in this one. It does in every cooling system out there, is it's going to cause scale buildup and corrosion. Giving you showing the Wrangler eTorque system, both the MGU and the power pack unit are liquid cooled. Excuse me. The MGU cooling is integrated with the vehicle's auxiliary loop. This is on a 2-liter. It does have a dedicated electric pump, a dedicated radiator and coolant reservoir completed to complete the auxiliary cooling system for the liquid cooled system. And as I mentioned, the 5.7 liter Hemi package, because of where the motor generator and the control module is located, it can be air cooled and cooled sufficiently with airflow across it. As far as some of the components, I mentioned the belt a little bit earlier. This is showing you the belt routing, just a graphic showing a computer generated graphic showing the belt routing, the tensioners and the idlers. The silver piece in the top left of that is actually a hydraulic tensioner. This is the piece that requires a special service procedure, and we've now introduced a torque wrench into belt replacement. I know that whenever I'm teaching class, I have guys say, well, why do I have to use a torque wrench on there? And the answer to the question is because that silver piece is expensive and fragile. And I'll get into the service procedure about that a little bit later. The battery pack, the battery power pack allows the ABS, or I'm sorry, excuse me, the brake pedal position sensor allows the ABS to monitor the exact pedal position. Some of the inputs that are going to be for this system, okay, when I come up to a stop sign and I get to a stop, I've got my foot on the brake. Instead of using a conventional on-off switch, we're using a pedal position sensor. This technology's been out there for several years. If that pedal position is down far enough and other enabling conditions are met, and I'll get into the enabling conditions in a few minutes, is that then we're going to have the engine shut off. Okay, all of the accessories will stay on. Since we're using a 48-volt system to power the 12-volt system, we're not going to have the voltage drop that we would normally have whenever a generator stops turning. We have a level constant voltage out of the system. This brake pedal position, as long as I have my foot past a certain point on the brake pedal and I have a certain amount of pressure applied, that the system is going to keep the engine off. Once again, as long as all of the other enabling conditions are met. When I start to ease up off of that brake pedal, long before I get high enough on the brake pedal, and when I say long, I'm talking fractions of a second, that long before I get far enough up for the vehicle to move, it's going to send a signal to the PCM in the hybrid control processor, and when it does, it's going to restart the engine. And the engine is going to be ready to go and ready to run by the time I get my foot from the brake pedal to the accelerator pedal. This system, compared to other start-stop systems that we've produced and that other manufacturers have produced, is considerably smoother than what I've seen using a conventional 12-volt starter. The 12-volt starter system accomplishes the same thing. It just does not operate as smooth as this one does. That's my opinion, okay? Some of the common components: transmission range sensor, that's an input to it. The example I will use is that when I pull into my driveway and I stop, sometimes when I get stopped before I reach up to put the transmission into park, the engine will shut off. When I do turn the transmission selector to either reverse or park, the engine restarts. The system is not active in reverse. It's not active in park or neutral. It's only active in drive. Has hood switches that are inputs to it. We have a switch. In some cases, there are two. Most cases, there are two hood switches, I should say. And the hood switches are so that if the hood is open, that this system is inactive. And what that means is that if the key is in the run position and the hood is open, the engine's going to be running. We don't want the engine to start unexpectedly while we have a technician under the hood. Hybrid vehicles pretty much the same way. Door switches, all of the doors have to be closed. If the doors are open, the system is inactive. Seat belt switches, if the seat belt is not buckled, the system is inactive. And the last bullet point there is a device called a hydraulic impulse storage accumulator. On the 8-speed transmissions, we have a hydraulic accumulator in the transmission that is going to store fluid pressure. So when the engine is off, the pump in the transmission is not turning. This accumulator is going to store fluid under pressure, so that when we let off of the brake, that the solenoid turns on, releases this fluid pressure, and we have clutch apply pressure at the same time that the engine starts, so that there's not a delay in applying the transmission. As far as operation, excuse me, what you're seeing here is a network configuration for a vehicle. And you see the hybrid control processor, the one that is circled, one on this graphic that also has a diagnostic trouble code in it because it's highlighted in yellow. And then you also see next to it is the BPCM, which is the battery pack control module. And then you see a line running from there up to the PCM. That indicates that these three modules do communicate with each other on a private network. The hybrid control processor and the PCM communicate on the powertrain CAN-C bus and the CAN-C network, because they do share information with other modules and get information with other modules on the vehicle. The battery pack control module, it needs to communicate privately, and that's probably not the best term to use. Needs to communicate in priority with the hybrid control processor and the PCM and share information at real time. So we put it on a private network. I showed the picture a little bit ago. Let me back up one. Okay. The battery pack control module, it says that it's going to manage the cooling systems for both the liquid cool and air cooled configurations. The battery pack control module is going to control the electric water pump for the liquid cooled unit and fans on the air cooled. Okay. There are cooling fans in this unit on the back side that you can't see in this graphic. When I'm driving down the road, and this is in generator mode, okay, the 48 volt generator is going to produce power, and it is going to charge the 48 volt battery. That is going to go through a converter, and that is going to go feed the 12 volt system. I talked about that a little bit already. Okay, this is a simplified graphic to show that. We do have some diagnostics, okay, and as far as eTorque operation. The blue line in here represents the high voltage battery cable, the 48 volt cabling between the battery pack and the motor generator unit. And you see that if it gets above, I told you already that it was a 48 volt system. If battery voltage gets above 51.9, the system shuts down. We turn on a check engine light. If battery voltage goes below 42.9, we shut the system down and turn on a check engine light. Okay, this is to protect all of the control modules and the unit itself. So we have a range there of about a 9 volt operating range that we want to stay within. The diagnostics, and this is ties in with the previous screen, is that we're going to look at the CAN-C voltages and set fault codes just like we for the private network between the hybrid control processor and the battery pack module and the PCM, just like we do on the CAN-C network. Okay, when you plug a scan tool into the data link connector, you're actually not accessing the battery pack control module directly. It is passed through the hybrid control processor. And you see here that these two are lit up in red. Not sure what we're trying to get across with the red in the graphic. Okay. When I turn the key on, this is the 3 lugs that is on the power pack unit. And it says, before removing the power pack, to disconnect the 12 volt battery at the battery itself, not at this location. Verify that the 48 volt contactors are open, and we use a voltmeter to do that. Okay, and the example they're using here, I've disconnected the negative battery cable. I then make sure that using a voltmeter that I've got do not have any voltage on the 12 volt post. The center of these 3 posts is ground. The one on the right is 48 volts. I want to see 0 there at all times if the 12 volt battery is disconnected. If the contacts in this contactor have welded themselves together, it is possible, and it is a fault, that the 48 volt post will still show 48 volts, or that the 12 volt post will still show 12 if the contactors have welded themselves together. When servicing the battery, this one is the one shown inside the vehicle. The yellow highlight here is a vent tube, and that vent needs to be plugged in. This is a lithium-ion battery. Has the same safety cautions and warnings as any other lithium-ion battery, but just the same as any battery, as it's charging and discharging, it does produce gases, and those gases have to be vented to the outside. This vent tube is shown coming off of the battery case, going through the floor pan to the outside. Okay. Cooling system service. This is showing the Wrangler with a 2-liter, and you see that there are 2 cooling system caps. One of the questions from from last week, or earlier this week, I'm sorry, when I did the same presentation, is that both of these systems do use the same coolants. Okay. As far as the pump on this, you have the pump, it actually gets a LIN bus message or LIN bus communications from the control module, and that is to tell the pump when to run. It is also to provide diagnostic information from the pump back to the ECU, and the purpose for that is so that we can read that information with the scan tool. As far as being able to directly access the pump and the module with the module that's inside the pump or inside the pump housing with the scan tool, that is not done. It's done through a LIN bus communication circuit. Some of the additional technologies that go with this. I mentioned that our purpose behind this is to reduce tailpipe emissions and to improve fuel economy. One of the things I'm going to tell you is that eTorque alone is not the only piece to this. It's not alone is not the key to the success. One of the things I did forget to say in here is that this system does allow, or does provide, I should say, some additional torque for the engine. On the 5.7-liter engine package, this system actually can assist with up to 130 foot-pounds of torque output for acceleration. I mentioned briefly that it also provides engine braking. In parking lot maneuvers, it will actually, I'm not sure that I can explain it because I can't see it on the scan tool, but it actually feels as if I've gone into an electric drive mode in some cases. I can't see it on the scan tool. I'm just telling you what I feel. One of the things that this does allow us to do is that we've gotten more aggressive with our multiple displacement system, with our cylinder cancellation. In the past, we did not go into a 4-cylinder mode below about 1,300 to 1,400 RPM. Now this system will allow us to go into 4-cylinder mode at about 1,100 RPM. Okay, what that does is at lower speeds, that allows this 4-cylinder mode at lower speeds. If we're only using 4 cylinders to drive the vehicle, fuel economy is improved. Part of the challenge with that is that when you are running on 4 cylinders at these lower speeds, that increases the potential for vibration and noise and harshness in the vehicle. To counteract that, we have mounted on the frame rails, one on each side of the frame rail, one on each frame rail, I should say, under the cab, an active vibration damper. What that does is that has got a weight in it, and it is timed to the engine. And when the engine is in 4-cylinder mode, we're actually going to move this weight back and forth in the opposite directions of the pistons on that side of the engine, and therefore going to cancel out the vibration from the part of the vibration from the 4-cylinder mode. The bottom bullet point here to help with some fuel economy as well is that we've also have an active air dam. The air dam on the bottom of the radiator is there to direct air up across the radiator and across the condenser and cooling system. Once you reach highway speed, that there's enough forced air through the system that the air dam is no longer needed. If it's sticking down, it's causing wind drag. So we have an active air dam that at highway speeds is going to retract and pull up and reduce wind drag coming under the vehicle. Okay, I have reached a point where I'm ready for some questions, if any of you have questions.
Thanks, Cecil. It's looking real good so far. So Dan, before you go and relay a question over to Cecil, as you scour the questions pane there and get something queued up, I just want to mention everybody, with the current COVID situation, hopefully we're on the downward slide of that whole thing. I think most of you are aware that ASE actually extended your certifications out through the end of the year in consideration of that. So you should have received contact from us about that. And hopefully that's helped you out in these kind of unusual times. Okay, with that, Dan, what do you got?
So Michael asked about, and so a couple of others asked about the fuel savings that Fiat Chrysler is achieving using this system. Do you have an idea what that is, Cecil?
I'm going to tell you what my experience is, and I've been driving Ram 1500 trucks for several years. I've got right now driving a 1500 with a 5.7 with this package on it. In town driving, and I will make this comment that electrification, will be a mild hybrid such as this, or hybrid vehicle, is stop and go in town driving is where the biggest advantage is. In town driving with this, I average between 17.5 and 19 miles per gallon. There's a lot of variables there, air conditioning on, that kind of things. But it's 17, I'm going to say 17 to 19 has been my experience. On the highway, I average about 19.5 to 22. Once again, several variables, load, weather variables into that equation. So the biggest advantage is in the in-town driving compared to a previous truck without this system. In-town driving, I was getting 14 to 15. Highway driving, I would get 19 on a good day.
Okay, and then several others, James and others, asked about the batteries. There's two separate batteries, correct?
That is correct. The 48-volt battery, the one in the pickup, is behind the seat, and then the 12-volt battery, which is under the hood in its conventional location.
And then what is the construction of the battery pack, the 48-volt battery pack? James asked that. Is it lithium ion?
Yes, it is lithium ion battery.
Gary asks if the parking brake is an input to the system.
I don't think so, and the parking brake is not, but the transmission range selector is.
And then Anthony and a few others asked for some clarification on these systems. Is there a button or a way that the consumer can turn the start-stop system off?
Yes, there is a button on the dash that it can be turned off. Default is in its active position. In other words, default is on.
And then a follow-up to that is, can a technician through the factory software available to the service professional adjust the start-stop delay time?
No, none of it's adjustable.
Do you have an idea of this from Michael, what the module strategy regarding how long the system is active with the brake pedal pressed before the engine is commanded to restart?
That's a very good question, because, and this may answer some of the other questions that people are going to ask, or that I'm predicting they'll ask, is how do we keep the cabin cool in a Texas day when it's 98 degrees outside? And the cabin temperature is one of the inputs as far as the time that it's going to stay in the off mode. And you may come up to a stop sign right now and the system shut the engine down and everything works like what you expect. And a half a mile down the road, you come to another stop sign or another intersection and stop, and the engine remains running. The difference is going to be is that one of our priorities is to keep the customer comfortable. And so if cabin temperature does not meet certain parameters, we're going to keep it running to keep the AC compressor running. If the system shuts down, shuts the engine down, I should say, and does what we expect, and the cabin temperature is within a correct range, but while we're sitting there, the cabin temperature comes up, it's going to restart the engine before we let off of the brake. And I've used cabin temperature for the primary example in my explanation. Battery voltage, coolant temperature, cabin temperature, brake pedal position, and I'm sure I'm leaving something out of the list, but there are several inputs that are going to determine how long the engine stays off.
Okay, and then several of the attendees are asking approximately what do you think the life expectancy of the 48 volt battery is?
I have to answer that one that I don't have an answer. I don't know. In talking to technicians, I have not talked to any technicians that have had to replace one yet. I didn't say there weren't any out there. I just said I haven't talked to them yet.
Okay, and then let me see, there's a lot of those. I gotta follow through them.
Okay.
Let's see. Do you know if on the evaporator has a thermal wax, if it's a thermal wax evaporator to keep the cabin cool for longer? That's from Phil.
I don't know the answer
Might
to
be
that.
a different topic. Okay.
Hey, Dan, I'm going to jump in for just a second. Cecil, maybe let's present that question a little differently. Are you aware of any changes to the air conditioning system itself that have been made in design, using this system?
No, the only change I'm aware of is the addition of temp sensors in the ductwork. And I'm going to say that was not solely due to the design of this system, because we have other vehicles where we have added temp sensors to the ductwork as well.
And a real quick related question, this is using YF refrigerant, correct?
Yes.
Thank you. Okay, Dan.
I would add to that the serpentine belt replacement interval. What is that on these? That's from Lewis and several others.
I believe it's 100,000 miles.
All right. Would you like to move to the next section, Cecil?
Sure, we can do that. I told you that we were going to get into a little bit of service procedure, and this is basically, this is on a 5.7 liter Ram pickup. And I'm not going to read the service procedure to you, but there's some highlights here that you need to be very aware of if you work on one of these. And the first, to remove the belt, okay, we got to get the belt off of it to get the unit off of the vehicle. And this is showing a drawing of the front of the engine. And it says to remove the stop bracket and the two screws from the stop bracket and take that loose. And it points out that's that yellow piece down there. Then it tells you to rotate the rotary tensioner clockwise, okay? And they call that out. And then they're going to have you put a pin in it, okay? We call it a grenade pin in our world. It's a 1/8 inch locking pin, okay? Then it, in big red letters here, says stop, steps for removing the belt. It says to compress the hydraulic tensioner using a 2-foot long torque wrench. It did not say a 2-foot long breaker bar. Okay, and use a 3-inch long extension, 1/2-inch drive. Set the torque wrench to 140 Newton meters. Okay, one of the questions that came up the other day was what type of torque wrench would you use here? And I would say a dial or a beam type. The key is we do not want to put over 140 Newton meters on this bracket and rotate it in a clockwise direction using slow, steady force. Okay, this is, you put the wrench on and you pull slow and steady. You don't put the wrench on and jerk on it. Okay, that hydraulic tensioner that is called out is actually being compressed. And I don't know if you can see my mouse or not, but it's the piece right just about in the center of that drawing, silver cylindrical piece. It looks a little bit like a tiny shock absorber. Okay, and we're going to pull that over and take the belt off of it. Okay. Then it talks about disconnecting the low voltage signal and the connectors and the 48-volt connection and unvolt all of the pieces to it. And the last line down there, number 6, says remove the unit from the engine, and be aware it weighs, according to this document, it weighs 40 pounds. I think it's heavier than that. Okay. And when you're bent over the front of the truck, it gets real heavy. Okay, now installing it, and this goes through the steps to install it, and all of this is in the published service information. Okay, and they're wanting everything done in a certain order and the bolts tightened in a certain order for alignment. Okay, when you get ready to put the belt back on, using that same torque wrench and 3-inch extension that you used to get it off, you're going to have to collapse that hydraulic tensioner. Once again, using the torque wrench, this is imperative. Do not go over 140 Newton meters. Okay. Now, one of the questions that has come up in the past and is that if I'm pulling on it and I reach 140 Newton meters, but I'm not loose enough to get the belt off, simply wait a few seconds and let the fluid pressure in that tensioner dissipate and go through the orifice that's in that tensioner, and then you'll be able to pull further. You'll actually, if you're using a dial type torque wrench, you'll actually see that the torque will fall off as you're pulling that up. Okay, so it's not like okay, I've gotten to 140 foot-pounds, but I can't get the belt off. What now? The answer to what now is wait a few seconds. Install the bracketry. Install as shown here, torque, and talk about the torque on the bolts, and then pull the grenade pin or pull the locking pin out. Okay, and that's the end of it. That's the service procedure. The part I wanted to get across and stress there was the torque wrench and the not over torquing that tensioner. Any more questions?
One of the questions I received was asking about the cooling system for the battery pack and the cooling system for the engine. They're separate. Do they have similar, or are they together? And do they have similar service intervals?
Similar service intervals. They are separate units, separate systems.
What about the coolant for those systems? Are they the same?
Yes, they are the same.
So here's an interesting one for you, Cecil. What about a Wrangler with the doors off on it? And you had talked earlier about having to have the door switches, closed, I guess, in order for the system to
Perfect.
operate.
That was from Roger. Yeah.
The Wrangler, when you take the doors off, has a capability to fool the door switches so the dome lights don't stay on, and that also allows for the eTorque system to function.
Any others in there, Dan?
Sorry, yeah, I was speaking, mute button. There's several folks that want clarification. They didn't quite follow what is when the engine stops and the vehicle is idling, or no longer idling, but just sitting at a stop, and the computer or the system wants to turn back on, what is actually starting the engine?
The generator is actually starting the engine on this system.
Perfect. So for those of you that were asking about, go ahead.
The 48-volt generator turns into a 48-volt 3-phase motor.
And so for those of you that are sending in the questions about starter wear, ring gear wear, and the like, there's none of that happening because the 12-volt starter is not functioning to start the vehicle when it's the start-stop system is involved, correct?
That is correct. When I go out to get into this truck to take off right now, the 12-volt starter is going to start the truck. Okay, and my commute is, I commute a long ways. I have several stops along the way. On my commute, this engine will shut down 8 to 10 times. And every time that it shuts down and restarts, it is restarted by the 48-volt generator, not the 12-volt starter.
And then Scott and Ken asked, and several others have asked, what year was this system introduced?
First application was on the Hemi engine was in the 2019 Ram trucks, and on the 2-liter engine was on the 2018 Jeep Wranglers. New body style Jeep Wrangler, I think that was 2018.
And then from Michael and several others, they've asked, does the MGU have a replacement interval similar to like the Toyota ones?
Not to my knowledge.
And then the belt replacement interval again?
I think that's 100,000 miles.
Okay. All right, I'm gonna scroll up here a little bit.
Dan, did we get a question about operator override for this system? And I guess the question is can the operator, owner of this vehicle, driver, whoever it happens to be, can they inactivate this system?
Yes. There is a button on the instrument panel to turn it off. And it, as I mentioned earlier, is that the system reactivates, or is default for the system is active. So every key cycle, it's going to come back to being active. If they want to disable it permanently, there's no way to disable it permanently. They have to press the button at every drive cycle.
And that's partially due to the fact that this vehicle's emissions compliance was attained with this system. Is that not correct?
That is 100% correct.
All right, thank you.
And then Enrique and others have asked about the air conditioning system in this particular vehicle. Does that still operate when the engine is shut off? Is there still cooling available for the passenger compartment?
What will happen is, and I described a little bit of that a few minutes ago, when I pull up to a stop, the engine shuts down, the blower still runs, everything from the driver's seat appears normal. Yesterday evening, I'll use that for an example. It was 98 degrees when I was on my drive home, and I drive west into the sun, so that makes it even better. And it stopped, and after about 45 seconds waiting on a stoplight, I could feel the outlet temperature of the HVAC system to increase. It never did increase to where it was uncomfortable, and that's one of the primary inputs as to when we restart the engine is the cabin temperature in the vehicle. In yesterday's example, it was about 45 seconds. I've seen it when in cooler weather or cloudy days to where it was a longer period of time that the engine stayed off.
And then Chris and a few others have asked about towing. And is the eTorque system disabled when towing?
No. It's active when towing as well.
Okay, and then I think that pretty much runs you through the majority of what we've done topic-wise. There's a flood of questions. It's hard to go through the whole pane and keep catching the same topic. So a very well-attended webinar.
I see 921 attendees.
Yeah, good group today.
Yes.
All right. Dan, well, thank you for managing the questions today, and a big thank
You
you to
bet, Dave.
Cecil for this great presentation on this very interesting system. Definitely some good insight into some new technology. It's a clear example of newer technologies related to powertrain control. This webcast was brought to you by ASE and the ASE Education Foundation. For announcements about upcoming sessions, please watch your inbox. On behalf of Cecil Williams, Bobby Bassett, and Dan Baumhart, I'm Dave Kappert, and this concludes today's webcast. We hope to see you online at another event soon. So long, everyone.